Welcome to Formnext 2023 and welcome to our Expert Insights here on Industry Stage in Hall 11, D72. I'm very happy that you are here in our live stream and here at our booth at the exhibition. Yeah, we want to start in our topic today, the Expert Insight organized to dive deep into supply chain issues, cybersecurity, and the questions of intellectual property. So a lot of people are concerned about intellectual property, and everybody was discussing supply chain issues since Corona, and now we are happy to have the experts here on stage to dive deeper into these topics. And I'm very happy to have the experts Aaron Frankel and Mike Vasi. Aaron Frankel is Vice President of Additive Manufacturing Program at Siemens Digital Industries Software, and his colleague Mike Vasi, he's Product Manager NX AM at Siemens Digital Industries Software. Good to have you both here, and you are together, so we will have a double presentation today.
Yeah.
Very good. Together they will show their understanding of a pragmatic additive manufacturing and will show how the digital thread is crossing the chasm for AM applications to scale. It's all about scale, but it's all about intellectual property. It's all about security when you're talking about software. And you are the software experts here, and we are happy to have you here and to show your insights. The stage is yours.
Fantastic. Thank you very much for having us. Thank you for attending today. My name's Aaron, and we're going to talk about pragmatic additive manufacturing, and we're going to talk about how to create that IP that's so important and how to turn that IP into products. And I'm here together with Mike Vasi, my colleague, and we're going to do some demonstrations of our software and how we do this. In order to succeed in additive manufacturing, we have to have a practical approach. That practical approach is something that I think is a little bit different. And we need to start thinking a little bit differently about additive. See, we're entering a new era of additive manufacturing. The era that we're leaving behind is one where we thought additive was a panacea. We thought that additive manufacturing could do everything. We thought that it could solve all of our problems. And we've learned that that's not the case. Okay? We've learned that we need to think differently about additive in order to move from this early market where we've seen success by a few companies into the mainstream market. And in order to do that, we have to think differently. And we believe that we have to start focusing on the product or the service that is going to give you a competitive advantage in the market. And it just so happens that additive manufacturing is one of the manufacturing processes that you can use to create that product. As we've been working with customers over the last 8 to 10 years on additive software and enabling companies to be able to create this IP in a digital environment, we've learned that there are 3 types of companies that have seen success with additive. And it's that thinking of these 3 companies which we have to apply in order to start taking advantage of additive as we cross the chasm into mainstream. The first type of company is the company that realized they needed to focus on the product and that the process was going to be easy to use additive and to scale it. But they had to think about the product first. The second type of company is the one that put a lot of energy into developing a disruptive type of product or application where only additive could make it. It wasn't using additive for the sake of additive. It was using additive to create some type of compelling competitive advantage in the product they were offering to the market. And the third type of company is taking advantage of the speed to market and the digitalization capabilities that additive brings in order to offer a greater, more valuable service to their customers. And I'm going to share with you some real examples of customers that are applying this new way of thinking. The first is Centavia, and I'm going to play a short video of the CEO, Brian Neff of Centavia, who is a customer of ours, and I believe emphasizes the fact that we have to think differently. So let's play this video.
In 2019, we looked at casting as sort of this amorphous industry, this huge industry, and it was exciting to say our process is better than that process, which I think it still is. But what we found in the last 5 years is the more product specific you can be, the more you can focus on a specific family of components, the more successful that you'll be. For example, heat exchangers, a thermodynamic component, is a great product for powder bed fusion. You have to focus on what you can do that's better than the traditional method. And for us, focusing on thermodynamics and propulsion systems absolutely is the right approach. And so we have greatly narrowed our focus from sort of general manufacturing technologies that we want to displace to specific products that we want to design and supply into the supply chain in a better manner.
Brian has a really powerful message here. When he first started his company, he was an open storefront producing any part for the aerospace industry using 3D printing. And he realized that he wasn't going to be able to build a successful business that way. He had an epiphany. He decided that he was going to focus on the product, and in this case, his product is advanced thermodynamic products. And then he developed a process to be able to make those products. He had a challenge. Once he recognized the business was available, he needed to have the systems in place to be able to support his scale. And that's where we came in and started to work with and help him. In order to scale his business from about 5 engineers working on 10 projects to 40 engineers working on about 60 projects, he needed to have a system that allowed him to manage his engineering data, his engineering process, control the process and the workflow for the aerospace industry, which is highly regulated. And in this case, he adopted Teamcenter, our product for engineering data and process management. Secondly, he needed to execute his process in production with high confidence and control. And in this case, he adopted our OpCenter products for MES, Manufacturing Execution System, in order to be able to execute his process on the shop floor. And then he connected the two worlds together so that he has a closed loop. When he has issues on the shop floor with work orders, he knows exactly what work order has a problem. He's able to pinpoint exactly where it's stuck in the process. He understands his engineering decisions that were made up front to execute that process and can go back and make the changes to the engineering process so he doesn't repeat them again. But the key point here is, in order to scale his business, first, he found his product, and secondly, he put the process in place to scale his business. The second customer is an example of finding a disruptive application that then only additive manufacturing could produce. In this case, our customer, Lima Corporate, developed the first implantable hip replacement. They developed a lattice-based material, trabecular titanium, and only that material can be produced using 3D printing. They design now knee replacements using our software, taking advantage of our tools to be able to print these types of knees, and they're scaling their business because of it. The process that they put in place is one where they develop the lattice. They've created features inside of our software in order to be able to design the lattice into different standardized shapes or different shapes and sizes of knees. They've optimized the design with topology optimization so that the material performs similar to the way your body would accept an implant. And then they're managing the entire engineering process in order to be able to support the regulatory requirements of the medical industry. And they're seeing a lot of success from that, reducing design time, being able to design more standardized components and then produce them at scale, getting them into the market to help them grow their business. And the third type of company is the type of company that is taking advantage of the speed to market and the digitalization advantages that additive manufacturing brings. And an example of this is Unlimited Tomorrow, a United States-based startup company that has developed personalized prosthetic robotic limbs for children. This company recognized that prosthetics were extremely expensive for kids. And by designing a personalized version and 3D printing it, they could do the design and the production at 1/10 the cost. Fantastic company, a great vision, and they needed to be able to have a tool set to support that vision. And in this case, they adopted NX Additive, both the design and the manufacturing planning perspectives, to be able to scan the patient's arm, their arm, and then be able to turn that scan into a model that then could be printed specifically for that person. Very exciting opportunity, and he's been growing his business because of this particular service he's able to provide only with additive. And the last example is a company that's also taking advantage of the strengths of additive from a on-demand manufacturing and a distributed manufacturing perspective. Schubert is producing machines for pharmaceutical, food and beverage industries, and when they send the machine to their customer, they're also sending a small 3D printer that they developed with it that they call the part box. And the part box is basically used to print specific components that need to go into the machine to configure it for the type of product that that machine is making at the time. Use the machine to produce a certain type of product, for example, let's say chocolate Santa Clauses. And then when we get into the spring season in time for Easter and we want to switch the machine over to chocolate Easter bunnies, we start thinking about all of the different components that are used to grip and move the chocolate through the process. All of those components are 3D printed on site next to the machine by collaborating with the engineers at Schubert on the design of what it is they need to put in the part, and then they're able to get these parts within a day. A complete change to the business model based on the capabilities and strengths of additive manufacturing. Now I'd like to hand over the presentation to my colleague Mike Vasi, who's going to show you some of the capabilities inside of our software. So Mike, it's all yours.
Yes, thank you, Aaron. I'm Mike. I work together with Aaron in the additive software side of Siemens. And as Aaron already mentioned, newer companies adopting additive manufacturing have a different mindset than the early adopters of this technology. And I would like to talk with you a couple of minutes. What does it mean from the software space? Today's companies are looking for solutions that are better fit for their specific problems. A company, for example, from the polymer industry has different needs than a company printing metal parts. Likewise, an aerospace company as Syntavia has different needs than a medical company as Lima. So different companies have different needs from different industries. The result is that software solutions for pragmatic additive manufacturing needs to cover different areas and needs to be both comprehensive and modular. Comprehensive, that means the software needs to cover different needs for different customers from different industries. And modular, because any given customer might have specific needs that are not covered by the standard solution out of the box. And since I'm part of the build preparation team, I want to share you a couple of examples where standardized solutions were not entirely fit for what customer need. So we had to develop specialized solution for these cases. In the first case, a company from the aerospace who wanted to have an optimized part connection to the build plate. Their solution was to design a part anchor that is inspired from, for example, the shape of the tree trunk at the base. So the tree trunk at the base does not have a full fillet, but it has an optimized connection that has an offset based on specific formula. That anchor provides, in the case of additive, better heat dissipation while reducing residual stress. This is a short presentation of the functionality that was not available out of the box, but for this customer who provide a specialized solution, we can provide the same solution within modeling context and also within the build preparation context. So we adapt the part design so that the connection with the build plate it is optimized for less stress and high heat dissipation. The customer can select a part geometry, can provide a base radius, and then we are automatically offset the geometry so that the connection it is optimized to the build plate. Creating this type of optimized geometry, it is not part of the standard package, and the customer was looking for a pragmatic solution, and we provided this with a custom design based on the standard application. At the top, we can provide a lattice structure to connect the part with the optimized support structure, and at the base, we can take into account a wire ADM post-processing operation. All these design structures are automatically associative, so that means if we are moving the part design, then the structure will automatically adapt to reflect the changes. In the second example, the customer wanted a different type of support structure that is created at the base of each part, and the support structure needs to be conformal with the part geometry. And this is an impeller that the customer provided, and we are able to provide an optimized support structure with a solid volume at the base. And as we go higher on the part geometry, we can take into account multiple isocline curves, and the support structure will automatically adapt to reflect the weight that will get supported. So we'll have a stronger support at the base with a stronger connection, a solid support, and then as we go higher and higher, we'll get a lightweight support, parametric, based on the type of the geometry that gets supported and the thickness of the support. Once again, this functionality was ranked as need to have from the customer side, and we were able to provide this through a specialized solution on top of our out-of-the-box solution. The additive industry is evolving to become more pragmatic, and I believe the software has a leading role in this because our software provides an end-to-end digital thread that covers the whole process chain from the idea generation down to the production. We have comprehensive standard features that scaling up production, for example, from 10 parts to 10,000 parts, and we have software modularity that can take into account and can accommodate specialized challenge at the customer side. As companies find their own unique value proposition, the software landscape becomes more differentiated and more pragmatic, and software, it is a main driver behind this because we can always provide a modular solution on top of our out-of-the-box software. Thank you very much for your time today, and we are happy to take any questions.
Thank you.
Yeah, one applause for these two. Thank you very much. I was right now a little busy and occupied looking at our Slido tool because you outside at the live stream and here in the hall, you have the possibility to ask your questions to our presenters here. I'm not sure if you're aware of it. Over there is a roll up, and then you can the QR code, and then you have access to Slido, and there you can give us your questions you might have. Right now, there is no question for you too. I was just checking it, but I was following your presentation, and I have the one or the other question for you. The first question would be, NX is a really broad software. You know, you cover the whole process chain, and as we saw, you can do a lot of things with the software. I'm not sure. Can you cover multi-material printing as well?
We can. With inside of NX, it's quite easy to be able to define different regions of the part and specify what material you would like to be able to use in order to produce that type of part. NX is architected to be able to support kind of multi-body, multi-volume parts, and we're able to assign materials and different characteristics to the different regions.
But talking about the support structures, if you have different materials, you need different support structures.
Specify different supports, different materials, different build strategies.
So how many materials there might be? Do you have a number for us, or how do you measure it?
It all depends on how many materials the customer wants to create the information for. But we have standard build strategies that come out of the box, different support types that come out of the box.
Okay.
And as customers continue to develop materials, which we have tools to be able to help customers formulate new types of powders and materials as well. When you define the characteristics on the materials card, we can absorb that information into NX, and then you can go ahead and apply it. We can manage the material card and distribute it across the engineering community as well.
If you have the intellectual property that's just your material and you brought it with you, but you have the specifics, you can upload them and then
keep it controlled within your corporate environment and protect your IP that way, but then enable your company to be able to use it. Yeah.
Yesterday we had the topic of the emerging markets, very special printing jobs. What about some exotics like printing electronics or printing biomaterials or something like that? Are you covering that as well, or is this too specific?
We've done some research work in printing electronics, and we've seen that our products can support those types of workflows. We have a couple of customers that we're working with and doing some research in that area. We think there's an opportunity there that fits our product base. In the area of bioprinting, we believe that it's an interesting market, but it's not one at the moment that we're putting much energy into.
It's no mass market for you right now.
Not at the moment. Yep.
Yeah.
Yep.
But
it's interesting. We're watching.
It will become. It will become someday.
Yeah. We're watching.
Maybe to touch our today's topic about supply chain, cybersecurity, and intellectual property. What about? Do you experience customers coming to you and are reluctant giving the data, working with you, asking questions about that topics, or is it just are they just asking technology questions?
It's a combination of both. So the customer has a totally interest in being able to transfer and communicate data in a safe way, and also to be sure that no data is shared outside a small circle of people that are involved in actually doing research work with that data.
Okay, how do you do it as Siemens that data is not corrupted or somebody else can have access to it?
We have a secure environment that provides certainty to the customers. That
what does it mean, a secure environment? Explain it to me, because I'm not so familiar.
The data is earmarked. As soon as the data enters the company, it is earmarked, and it has a dedicated visibility only for example, for the development team that is responsible for analyzing the data and provide the solution to the customer. No other person outside the small development team involved directly with the data has access to that data.
Okay, and when you want to add something?
In addition to this, as you can imagine, Siemens has many customers in the aerospace and defense industries in many different countries. And our customers have been working with us for decades on helping us to improve our software. And each customer has a unique ID when they become a customer and have licenses to our software that gives them access to our support center. When they come into support center and they issue an incident, they can tag that data that they're submitting as specific to them or ITAR controlled or controlled data, in which case only people that are able to access that information gain access to it in order to address the issues.
We are talking about a lot of data and about different production sites maybe or different. Are you working with a cloud service or?
Yeah, we have a big strategy is to move into SaaS and move to the cloud, and we offer many products on the cloud today. And we're able to offer secure environments for our customers to be able to work with their data inside of the cloud and keep it controlled and keep it safe. Yep.
Okay.
Yeah.
We're not forcing any customer to jump to the cloud, but we are ready when they are.
Okay, so you two are still here at the exhibition. So if anybody has another question, a different question, you can have contact to you too. Thank you very much, Aaron. Thank you very much, Mike, for being with us and brought your insights here on stage. And have a successful fair. And one applause for the two. And if you want to make contact, they are still here.
Hall 11.1. You can find us there at the Siemens booth. Thank you very much for joining us. Appreciate it. Thank you for having us.
Thank you. Thank you too. Yeah, after a short break, we will have the next application insights here on stage, and see you then.